All right, so we've talked about in the past whenever we're going to have an inconsistent system versus a consistent system. So in this case, if your row reduced echelon form produces ones on each part of the diagonal, and you can see clearly what each letter is, and this is going to be a consistent system, and you know what the answer is in this case. 1 is X, 5 is Y, Z is 2. In this next case, this is going to produce an inconsistent system. You'll notice on the very last row there are no variables. No X, no Y, no Z, but somehow that's supposed to be equal to 2. There's no way that can happen. So in this particular case, you have a contradiction, which means that this is going to be an inconsistent system because it has no solution. We have also looked at infinitely many solutions as well and how to deal with those, how to find those infinitely many solutions along the line. So this is what I'm going to focus on in the next example. So you'll see here, if this was your final result, then you have zeros on the very last line, which means that last variable, this is 0 times z. And because z times anything is going to be 0, that means z can be whatever it wants. So we have an equation for x, we have an equation for y, and we're allowed to let z be whatever we want. So what we would do is we would solve this for x, we would solve this for y, and then z would be whatever letter we want. We'll let it just be t in this particular case. So when you solve for x, you'll get 2 minus 5z, y will be equal to 2 minus 3z, and then z is equal to t. So that when you put the three of those together for your infinitely many solutions, you have 2 minus 5t, comma 2 minus 3t, and t. So as long as you follow this pattern, you can allow t to be whatever you want, and then x would be based on whatever t is, and so would y as well, and that would be your infinitely many solutions, so this would be a consistent system as well. So here's going to be the example that we're going to do together. I know it says you try, but we'll do this one together. It says find the complete solution of the system. So we have x, y, and z. We want to figure out what we can plug in there to make this a true system of equations. So starting off with your augmented matrix, we'll have this left side here equal to our coefficient matrix here. This will be our constant matrix. We put it together as our augmented matrix. They didn't put the vertical line down here in the middle. If that helps you and you want to be able to separate those off, you may do so, but you don't have to. So first thing I want to do, I want to make sure that I have a 1 here if I can make it happen. If I can, it's not that big of a deal. I can take care of it last. But for right now, I can make it happen. So I'm just going to simply switch row 1s in row 3 so that instead I have the 1 in the first row rather than in the third one. Now, using this, remember my goal is to make this a 0 and this also a 0. So I'll multiply this first row by 3 and add it to the second row to replace the second row. I said 3. I'm such a silly goose. I meant to say that for the third row. I do want to multiply it by 3, but I'm going to multiply it and add it to the third row. That's my bad. I'm sorry. For the second row, to make this 0, we're just going to simply add row 1 and row 3. So we're going to do both of those at the same time in this one. So if I add row 1 and row 3, that'll produce a row 1 and row 2. I apologize, I keep saying row, I apologize. Anyway, add row 1 and row 2. So when I do that, this becomes 0, 1, these two added become 3, these two added become 1. Now for the next one, I'm going to multiply this by 3 first, and then add it. If you want to pause this video at this point so that you can do that on your paper, you may do so. So this becomes 3 plus negative 3 is 0. That's that. 3 plus negative 5 is negative 2. Negative 30 plus 36 is 6. And then negative 12 plus 10 is negative 2. So we've done 2 steps in one for this particular matrix. Now, since I already have my 1 here, I don't need to do anything here, so I can go ahead and take care of this one and this one. So remember, your goal too is to make the 0 in this first row and then 0 in this third row for the second column. Okay, so in order to do that, I'm going to take twice the second row. I'm going to multiply it by 2, and then I'm going to add it to the third row so that I can get my 0 here that I want. When I do that, you'll notice that I end up with all zeros. This will become 2, negative 6, and 2. But when you add that to the third row, it completely goes away. So now I have all zeros at the bottom. This is going to be your row echelon form because the zeros are all the way down here at the bottom. And so now you know that you're going to have an infinitely many solutions. Oh, this continues. Okay, so it's going to keep on going to put it in row reduced echelon form. So now to put this in row reduced echelon form, I need a 0 here. So we're going to take row 1 and subtract row 2, and we're going to replace row 2 with that. So, no, we're going to take row 1 and subtract row 2 and replace row 1. I apologize. That's what it says here. We're going to replace row 1. So we're going to do 1 minus 0, which gives me my 1 here. 1 minus 1, which is that's where that 0 came from. And then negative 10 minus negative 3, which produced my negative 7 here. Negative 4 minus 1, which is going to be the negative 5. And so now you'll notice that we have this, we can't make this go down any further. Why they did that, put that 0 there, I'm not exactly sure. You could have done this without that, but we'll continue. It's not that big of a deal. All right, so from here we now have that our first equation is going to be x minus 7z equal to negative 5. Our second is going to be y minus 3z equal to 1. And technically my last row says 0z equals 0. And so now I can allow z to be anything because I have infinitely many solutions. And so in this case, we are going to have x equal to 7z minus 5 and y equals 3z plus 1 if I were to solve each of those. Since z is going to be allowed to be anything, we'll replace that with t. And so my final solution is 7t minus 5, comma, 3t plus 1, comma, t. Here's a couple of examples for t's. If you were to plug those in, if t was equal to negative 1, 0, 2, and 5, for example, we have infinitely many solutions where these 4 are just part of those. But you'll notice things like, for example, 0, 0, 0 is on a solution, 1, 1, 1, and so forth. So even though there's infinitely many solutions, there's also infinitely many solutions that will not work as well. Okay, and that's it for this PowerPoint.